The FIA has just stunned the entire paddock by launching a new investigation into McLaren, and insiders claim this fresh probe could be even more explosive than the original Las Vegas disqualification that shocked fans around the world. The official measurements show that Oscar Piastri's plank dropped as low as 8.74 mm and Lando Norris registered 8.88, both figures confirmed repeatedly with tools calibrated to 1,000th of a millimeter and recorded with McLaren staff present throughout the inspection. Now the FIA wants to understand how two cars running separate strategies produced nearly identical wear patterns and whether the team miscalculated its ride height so precisely that the breach was unavoidable from the very start of the Grand Prix weekend. And before I reveal the new evidence the FIA is inspecting right now, make sure you subscribe to the channel because this investigation is expanding faster than anyone expected, and the next discoveries could rewrite the final chapter of the 2025 season. The Las Vegas weekend became a turning point the moment the FIA completed the first round of plank inspections and discovered that both McLaren cars were running below the minimum legal thickness. The official document recorded Piastri's readings as 8.96, 8.74 and 8.90 mm, values obtained with equipment calibrated to 1,000th of a millimeter. These numbers did not appear once. They repeated exactly across multiple checks, confirming that the wear pattern was stable and predictable. This level of consistency triggered immediate concern inside the FIA because uniform measurements often indicate a systemic behavior rather than an incidental strike on a curb or an isolated on-track moment. The situation escalated further when the FIA revealed the findings from Norris's car. His plank measured 8.88 and 8.93 mm, again confirmed repeatedly with McLaren staff present. The FIA's engineers noticed that the values fell within the same tight band as Piastri's, suggesting that both cars experienced nearly identical floor compression across the entire race. This symmetry forced the governing body to reconsider the original conclusion. What looked like a simple breach now resembled a deeper structural pattern that demanded further explanation. The FIA believed that identical readings could not be dismissed as coincidence. They reflected deliberate or unintended setup behavior that spanned the whole team. The FIA also reviewed how the weekend's disrupted practice sessions influenced the outcome. Las Vegas offered very little long-run preparation, with multiple early interruptions preventing teams from collecting the crucial data needed to validate their ride height simulations. McLaren entered qualifying with a model built on incomplete information, and once the race unfolded under colder than expected night conditions, the plank experienced more compression than their predictions suggested. The FIA understood the context but noted that incomplete data usually forces teams to leave larger safety margins. McLaren did the opposite. They ran a configuration so precise that even a slight variation in surface temperature pushed their floor into illegal territory. When inspectors examined the physical plank surfaces, the uniformity of the wear became impossible to ignore. The erosion did not show sudden drops or isolated abrasions, but rather a smooth and consistent pattern across all three reference points. This type of wear is associated with a floor that runs too low for an extended period, not one that temporarily dips during a single incident. The FIA highlighted this detail in the report, noting that such patterns often indicate an underlying issue with the ride height philosophy. Uniform wear across both cars raised the possibility that the team underestimated the aerodynamic load of the Las Vegas circuit, creating a failure that was consistent from the green light to the checkered flag. As the FIA evaluated the event further, they recognized how the extreme night temperatures amplified the problem. Colder air increased the density around the car, producing more aerodynamic load than the models had predicted. More load meant more vertical compression and therefore more plank contact with the track surface. Because both cars were set close to the 9 mm limit, even slight reductions in tire pressure or reductions in track temperature pushed the floor into a zone where legal margins evaporated instantly. The FIA now suspects that the setup placed both cars at risk without leaving space for environmental fluctuation, and that this precise setup choice may have been the root of the scandal. The final factor pushing the FIA toward a new investigation was the combination of symmetry, precision, and repeatability surrounding every piece of evidence. When two cars from the same team breach the same regulation by almost identical margins, when the measurements repeat across multiple inspections, and when the wear pattern shows consistent and predictable erosion, regulators look deeper. They want to understand whether McLaren misjudged the demands of the Las Vegas circuit or whether the team's modeling created a situation where illegality was unavoidable. This is why the scandal now deepens. The FIA believes the data tells a story much larger than a single disqualification, and they intend to uncover each layer before the season concludes. The core problem behind the new investigation emerged when the FIA compared the plank measurements from both McLaren cars and realized that the numbers aligned too closely to be considered random. Piastri's readings of 8.96, 8.74 and 8.90 mm showed a pattern of consistent compression across the reference points, a sign that the floor had been running too low throughout the race. These values were reproduced in repeated checks, confirming that the wear was not an isolated anomaly but a stable mechanical behavior. For the FIA, this raised an immediate question. If the wear was predictable, why was it not predicted by the team's pre-race modeling? The issue deepened further when the FIA analyzed the readings from Norris's car. His plank recorded 8.88 and 8.93 mm, creating a numerical grouping nearly identical to that of his teammate. This symmetry placed McLaren under pressure because two cars producing the same type of breach suggests that the root cause lies in the team's setup philosophy rather than in unpredictable on-track events. The FIA viewed this alignment as evidence of a systemic miscalculation rather than a stroke of misfortune. Such consistency is rare in circumstances driven by curb strikes or accidental floor damage. It reflects a predictable load pattern that the team either underestimated or failed to account for. Another concern arose from the nature of the wear itself. The FIA report highlights that the plank erosion was uniform, smooth and present across all designated measurement points. There was no sudden abrasion or deep cut that would indicate a single moment of heavy impact. Instead, the surface told a story of prolonged contact with the circuit, the kind that emerges when a car runs below its safe ride height for extended periods. This type of wear indicates more than a random race event. It reflects a misalignment between engineering expectations and real-world behavior. The FIA's technical team noted that this level of uniformity often emerges when a baseline setup is placed too close to the regulatory threshold. The FIA also questioned the explanation McLaren initially provided about limited practice running. The weekend interruptions prevented teams from collecting the long-run data needed to validate ride height settings under full race conditions. While this is true, the FIA argued that incomplete data normally encourages caution rather than precision. If the team lacked the information to fully confirm their modeling, then setting the car near the 9 mm limit introduced an unnecessary risk. The inspectors reviewed how the team used simulations to estimate tire deflection and aerodynamic load, and the uniform wear across both floors suggested that these simulations may have been too optimistic for the extreme conditions of the Las Vegas night. Temperature also played a central role in the problem. The FIA noted that colder conditions lower tire pressures, which reduces the effective ride height of the car. This effect is predictable and must be accounted for in the setup process. The governing body observed that both McLaren cars experienced a consistent level of ground contact, which implies that the team may not have allotted enough margin to compensate for environmental fluctuation. Because the plank thickness rule is absolute, even small deviations create automatic illegality. The FIA now views this as an engineering decision that carried consequences the team did not fully anticipate. The final aspect that pushed the FIA to escalate the matter was the cumulative weight of the evidence. Two cars showing nearly identical illegal measurements. Erosion patterns that reflect long-term compression rather than accident-based damage. A weekend with limited validation opportunities. A setup philosophy that may have pushed the car too close to the edge without sufficient protection. All of these details formed the foundation for the new probe. The FIA wants to determine whether the breach stemmed from a misjudgment, a structural flaw in the modeling, or a setup direction that left no room for the unpredictable nature of the Las Vegas circuit. This is the problem at the center of the scandal and the reason the investigation now deepens. The engineering pressure at McLaren escalated the moment the FIA compared the illegal measurements with the team's expected ride height models. The official readings showed that both cars ran below the legal limit by microscopic values repeatedly confirmed at 8.96, 8.74, 8.90 for Piastri and 8.88, 8.93 for Norris. These numbers reflected extreme precision in the team's setup, leaving very little margin for the unpredictable behavior of a brand new circuit. Engineers realized instantly that any tiny variation in aerodynamic load or tire pressure could have pushed the floor into illegal territory. The FIA now wants to understand why the baseline configuration left insufficient buffer for these conditions. As McLaren reviewed its weekend preparation, it became clear that the lack of long runs during practice had robbed the team of crucial validation data. Multiple interruptions early in the weekend meant that engineers had limited information about how the floor would behave under full fuel and cold night temperatures. Under normal circumstances, a team would increase its safety margin to counteract the uncertainty. Instead, the plank wear suggested that McLaren relied heavily on simulation rather than confirmed track behavior. The FIA is now examining whether the team misjudged how the new Las Vegas surface would evolve or whether they underestimated the physical load that the circuit would impose from lap 1 to lap 50. Temperature was another decisive factor in the engineering collapse. The Las Vegas night cooled quickly, lowering tire pressures and reducing ride height more than expected. Lower pressure means the tires compress further under load, pushing the plank closer to the asphalt. The FIA noted that this effect occurred consistently across both McLaren cars, which implies that the ride height model did not adequately account for thermal behavior. Because both cars dipped below the 9mm limit by nearly identical values, the FIA believes the compression pattern was predictable rather than chaotic. If it was predictable, the question becomes why McLaren did not anticipate its magnitude. The uniform wear pattern on both planks provided the FIA with one of the strongest pieces of evidence. The erosion did not show the sudden gouges or erratic marks that appear when a car hits a curb too aggressively or suffers an isolated impact. Instead, the wear was smooth and evenly distributed across the measured points. That type of pattern is associated with long-term ground contact at a consistent ride height, not a single moment of damage. The FIA highlighted this detail because identical wear on two independent cars rarely comes from coincidence. It reflects an engineering decision that placed both vehicles into the same mechanical window. McLaren's aerodynamic approach added another layer to the technical analysis. The team pursued an aggressive low ride height to gain stability and downforce on a circuit with unusually long straights and high-speed sections. In theory, this configuration offered performance benefits, but it relied on having complete data to balance the load distribution. Without long runs during practice, the team may have underestimated the compressive forces produced by cold air density and maximum fuel weight. The FIA now suspects that the combination of low temperatures and aggressive setup created a scenario where the plank was destined to fall below the limit. This concern sits at the center of their renewed probe.